Hello and welcome to episode 8 of the Automation Podcast, brought to you by insightsinautomation.com. I'm your host, Shawn Tierney, and on today's show we'll be discussing the different load modes for non-volatile memory when used with the ControlLogix and ControlLogix processors. So similar to other Allen Bradley PLCs, the ControlLogix and ControlLogix processors give you 3 modes for loading from non-volatile memory. These modes are user-initiated, on power-up, and on corrupt memory. Now, user-initiated is pretty self-explanatory. The only way that's going to load from non-volatile memory is if you initiate it manually yourself using RSLogix 5000. The next mode, on power-up, means that every time you cycle power to the PLC, it's going to load from non-volatile memory. Now, that's not always good if your operator has entered a bunch of parameters on an HMI somewhere, and then every time you cycle power to the machine, those disappear because it's loading from non-volatile memory. He's not going to be very happy. So we don't often use the on power-up mode. The final load mode is on corrupt memory. And this is very popular because what this says is if my PLC's memory is corrupt, i.e. scrambled somehow, maybe a power surge or whatever, then I will load my memory from the non-volatile image. Think of it this way. If your hard drive crashes, it may not be ideal to grab backups from some other location, but grabbing a backup is much better than having nothing at all. The same thing is true with a PLC. It may not be ideal to be using an old image off of the non-volatile memory, but an old program versus no program is typically a much better situation. Not always, but typically much better. So now let's talk about how you would actually go about testing each of these modes to ensure you understand it and also to prove to a customer or client that it actually works. So to start, we need a couple of things. First of all, we're going to need our computer with RSLogix 5000 on it. We're going to need to be connected to a ControlLogix or CompactLogix. We're going to need 2 different programs. I'll call them Program 1 and Program 2. The reason we need 2 is we need a second one to ensure that the first one is overwriting it and loading from the non-volatile memory. So when you get all that together, if you're going to actually try this while you listen to the podcast, go ahead and pause the podcast now and then unpause it when you're ready to go. Okay, so we have our computer, we have RSLogix 5000 open. Let's go ahead and open our first program, Program 1. The only thing that needs to be different between Program 1 and Program 2 is that you know they're different. Really don't need any special code in either. We just need to be able to identify them as being 2 distinctly different programs. So you have Program 1 open. We need to go ahead and download that to our ControlLogix, and then we want to go online and then put the programmable controller in program mode. Okay, we have Program 1 in the programmable controller. The programmable controller is in program mode. We insert if it's not already inserted, we insert our non-volatile memory. And now we're ready to load our program onto the non-volatile memory. To do that, inside of RSLogix 5000, you're going to go to controller properties. Now, there's 2 different ways to get there. You can either right-click on the controller organizer and select controller properties, or underneath that little graphic of the key switch on the toolbar, there's a little button there with a PLC on it. Click that, and that'll bring you to controller properties as well. So inside of controller properties is the tab labeled non-volatile memory. This is where we store our program to non-volatile memory, as well as where we would load it from non-volatile memory. So for our first test, we're going to store our current program, Program 1, to non-volatile memory with the load image setting set to user initiated. So go ahead, make that change, and then press Store. Now, as RSLogix will tell you, this is going to take a moment, and you're going to have to watch the lights on the front of the processor to see when it's done. But after a minute or 2, your program, in our case Program 1, will be stored to non-volatile, and you'll be able to reconnect to the processor. So go ahead and reconnect to the processor now. Now at this point, Program 1 is in non-volatile, and Program 1 is still in the memory of the processor. So let's open up Program 2, download it to the processor, and then cycle power to the processor to ensure that Program 2 remains in the processor's memory. In other words, we put Program 1 on the non-volatile storage and set it to only load on user initiated when we do it ourselves. So we want to make sure that we can put Program 2 into memory, cycle power, and still have Program 2 in memory. So go ahead and do that now, cycle power to your controller, reconnect, and if everything worked well, Program 2 is still there. Program 1 is on the non-volatile, but is set to only load when we initiate it. So let's go ahead and initiate it and see if it comes back. Go into controller properties, go into the non-volatile memory tab, click on the load button, and after a few seconds or minutes, our program 1 should be reloaded from the non-volatile memory into the controller's memory. So reconnect to the processor and verify that program 2 has been wiped out by program 1. Okay, so test 1 went well. Let's go ahead and try test 2. And for test 2, we're going to change the load mode to on power up, meaning every time I cycle power, the controller should load from the non-volatile memory. So let's go ahead and try that now. The first thing we'll do is, well, we know we just loaded program 1 back from the non-volatile into memory. So let's go ahead and store that again. In the non-volatile memory tab of the controller properties, we'll press the store button, but this time with the load mode set to on power up. So open controller properties, open the non-volatile memory tab, and where you see load image, change that to on power up. And then go ahead and press the store button again. So once the processor is done storing our program to the non-volatile, we'll want to go back online and download program 2. Now with program 2 downloaded to the controller, because we set the non-volatile memory to load on power up, when we cycle power, it should load program 1 back into memory. So let's go ahead and cycle power to the controller, reconnect, and verify again program 2 has been wiped out and program 1 is back into memory. All right, now if everything's going well there, we're ready to try our final test. This test would test loading non-volatile memory when the processor's memory is corrupt. Now I want to point out that the processor having a default program is not the same as the processor having corrupt memory. When you power up a processor and it doesn't have a program in memory and it doesn't have a non-volatile memory source to load a program from, instead of leaving the memory blank, it loads a default program. Once that default program has been loaded, if you put in a memory card that says load on corrupt memory, your processor's never going to load from that card because memory's not corrupt. It has a default program in it. So the way we test this, and the way you get around this if you powered up your PLC before putting your non-volatile memory in, is to erase the processor's memory and power it up with the non-volatile memory installed. So on an older ControlLogix or ControlLogix that has a battery, we simply just remove the battery and turn off power. On the newer ControlLogix and ControlLogix, we have to hold down that default comms button as we power the processor on to erase the processor's memory. So okay, let's go ahead and do our test. First, remove your non-volatile memory card. Then, on your controller, either remove the battery and cycle power, or press down on the default comms button and cycle power. Now you should notice when you do that, when you try to go online, you're going to get the note saying, hey, I got the default program loaded. The reason is we erased the processor's memory, but also removed our non-volatile memory card. So to continue with the test, go ahead and reinstall the non-volatile memory card, download program 1 to the controller, and go online and open up controller properties, open up non-volatile memory, and change the load image mode to on corrupt memory and store that program to your non-volatile memory. Once that's done, I want you to go back online with your processor and open controller properties, go to non-volatile memory, and just double check that that's been transferred to your non-volatile memory card. It has? Okay, good. So now what we're going to do is we're going to turn the processor off, pull the battery, or hold down that default comms button while we power the processor on. This will erase the processor's memory, and when it first loads, seeing that it has nothing in memory, it'll look for our non-volatile memory, and as we've set it to load on corrupt memory, it should load our program from there. Okay, power on your PLC with the battery out or holding down that default comms button. Give it a few minutes, and then go online and see what program is in the processor. And here we go. We now have program 1 back into the controller's memory. Well, that's it. That's all the steps in testing the 3 different load image modes of non-volatile memory on the Compact and ControlLogix. If you have any comments, questions, or corrections to this information or these procedures, please don't hesitate to share them with us by replying to this episode's blog post at theautomationpodcast.com, which can also be reached by using our short URL, link2tap.com. And as always, you can stay up to date with all the Insights websites at insightsinautomation.com or by following me on Twitter, Facebook, or LinkedIn, where I'm known as Mr. Shawn Tierney. Now, before we go, let's take a look at what's coming up on our next podcast. Tune in for episode 9 next week, where we'll be discussing transferring software registration of Rockwell and Allen Bradley software products. Well, that's it. That's it for episode 8 of the Automation Podcast. I'm your host, Shawn Tierney. Until next time, peace. Peace.